A presentation on ignoring signals by Rohan Sarmandal for the course Linux System and Shell Programming CS 4154. Let's talk about signals in Unix-like operating systems. So signals are software interrupts or notifications which are sent to a process or to a specific thread within a process. They're a form of IPC, which is inter-process communication. Signals are handled by the kernel and individual processes. They notify processes about some event. Each signal has both a numeric representation and a symbolic name. For example, the signal SIGINT has the numeric representation 2 and it's used for interrupts. So let's look at some examples of signals. We have SIGTERM, whose numeric representation is 15. Uh, this signal is used as a termination signal. It requests a process to terminate gracefully, and we can see the code or syntax for using this signal. Similarly, we have SIGKILL, which is the kill signal. It forces the process to immediately terminate. The numeric representation for this signal is 9. We also have SIGINT, whose numeric representation is 2. This is the interrupt signal. It is sent when the user wants to interrupt a process. Whenever we press Ctrl C in the terminal, it is equivalent to sending the SIGINT. These are three signals, but there are many more. So whenever there is a pending signal, there are three actions that can be taken. First is we can perform the default action of that signal, represented by 0. We can choose to ignore that signal, represented by 1, or we can perform any user-defined action or function, which can be represented by any other value. Since the topic of this presentation is ignoring signals, we'll be looking at the middle case. So ignoring signals in a Unix-like operating system involves instructing the process to take no action when a specific signal is received. This can be useful in scenarios where certain signals, such as SIGTERM or SIGINT, might otherwise cause a process to terminate, but the process needs to continue running. When programming in C, the signal function, or more modern approaches like SIGAction, can be used to set a signal handler for a specific signal. Setting the signal handler to sig underscore ign ignores that the process should ignore the signal. So here we can see the code which we might use for ignoring a specific signal. In this case, we want the SIGTERM signal to be ignored. Let's look at the syntax in detail. In Unix-like operating systems, the signal function is part of the C standard library and is used to establish a signal handler for a specific signal. A signal handler is a function that gets executed when a particular signal is received by a process. The signal function, which we saw on the previous slide, has the following general syntax. So if we look at the various parameters in this, signum specifies the signal for which we want to set the handler. It can be any valid signal number like sigterm, sigint, etc. The signal number is defined in the signal header file. If we look at the next parameter, which is the handler, it's a function pointer representing the signal handler. It can be set to any one of the following values: sig underscore DFL, which takes the default action, sig underscore IGN, which ignores the signal, or a pointer to a custom signal handler function. And the return value of this function is the previous value of the signal handler. So let's look at the code for ignoring signals. Over here in my Ubuntu VM, I've written a code uh, for ignoring signals in C. So as we can see at the top, we've included the signal header file, which is necessary when working with signals in C. We have a main function where we've used the signal function. The first parameter is the signal we want to work on, which is the SIGINT or the SIG interrupt signal. As we saw before, this is the equivalent of pressing Ctrl C in the terminal. And we've passed the sig underscore ign, which means we want to perform the action of ignoring this signal whenever it is called. To demonstrate this, inside a while loop, we've set up a print statement which for every 1 second it prints waiting for a signal. If we look at the loop carefully, we can see that it does not have a termination condition. and it will keep on executing infinitely. So this is what the code does. I've already compiled this code as a IG and SIG over here. So let's open up the terminal and run it. Sorry, that was the wrong command. So as we can see, waiting for a signal is being printed every 1 second. Now if we press Control C, let's see what happens. Despite pressing Control C, we can see that the process has not been interrupted and keeps on going on. Even if we press Control C again, we still the process does not get interrupted and keeps on getting stuck in the infinite loop. So as we can see, we've essentially ignored the SIGINT signal. So a summary. Ignoring signals in Linux involves configuring a process to disregard specific signals, preventing them from interrupting its normal execution. In this case, we'd ignored the SIGINT signal. This is often achieved by using the signal function or signal handlers. So first we looked at signal handling in Linux, where signals are software interrupts used to communicate with processes. Each signal has a specific purpose, like termination, interruption, or user-defined actions. If we look at Then we looked at ignoring signals. So the signal function or signal handlers are used to handle signals in Linux programs. To ignore a signal, the sig underscore ign constant is used. Then we looked at some example code. The simple example we saw is by setting the signal handler to sig underscore ign to ignore the specific signal. The process continues normally, which is our while loop, despite receiving the ignored signal. Then we compiled our code using a C compiler and we ran it on our Ubuntu system. What are the use cases of ignoring signals? So ignoring signals can be useful in scenarios where certain interruptions are not desired. It allows processes to continue running without being affected by specific signals. It also allows a graceful termination. To stop a process that ignores a specific signal, a different signal can be sent to trigger a graceful termination. Ignoring signals is common in daemon processes, background tasks, or critical system components that should not be abruptly terminated. Thank you.